Hello friends, welcome to the today's online lecture. We today will be discussing some of the basic terminologies which we'll be using in the language of mechanics in order to discuss the Newton's laws of motions. So let's start our today's discussion with the first terminology which is essential to discuss the mechanics, that is called as the displacement. Every day we are observing so many objects, they are performing motions. For example, a car is traveling on the road, or we have considered the example the water is flowing in the in the river, or the scooter moving on the road. These are the examples which we are observing in our daily life. If you consider a first example which I had given you, that is, for example, there is a car which is moving from, let us say this is point A to point B. Okay, suppose there is a car which is moving from point A to point B. Let us say this is a car which is moving from point A to point B, for example. Now, when I am saying that this car is moving from point A to point B, let us consider at T1 the car is at this position at A, and it is going from point A to point B, and it is taking a time T2. Okay. For this, what I'll do, I'll just draw a axis to this, so that let us call this as my y-axis and let us call this as my x-axis. Okay, so this will be my origin. If I assume that the object initially is at the distance x1 from the origin O, and let us say after traveling from point A to point B, the object is going to the position B at time T2. Let us say its distance from the origin, it is x2. Okay, now we have to discuss what is displacement. Displacement, it is defined as the change in position of an object which occurs over a certain time interval. Okay, so we will first note it down and then we will calculate what is the displacement over here. So I will write it over here. It is defined as the change in position, of an object, over a time interval, Here in this case, we have considered an example of car which is moving from point A to point B. So, first of all, I will just ask you a simple question. What is the position vector of point A? Position vector of point A. It is x1 bar. With respect to origin, its position vector is actually OA bar, and OA bar is nothing but this is the position vector of the point A. Okay. Now, similarly, if I ask you the position vector of the point B, which is OB bar, the position vector of point B, it will be x2 bar. Now I know that OA bar was the position of the object at a time interval T1, and B bar is the position vector of the car at a time interval T2. Now I want to calculate the displacement, so that is the change in position. So I know that the car has traveled from point A to point B. So the change in position is what? It is AB bar. The change in position is AB bar. And how will you calculate this AB bar? In the terminology of vectors, we have studied in our earlier classes that AB bar, any vector can be determined by position vector of final point, position vector of B minus position vector of A, position vector of A. So position vector of B, it is with respect to origin, it is x2 minus position vector of the first, it is x1, and I know that this displacement is along the x direction. So this x2 bar or x1 bar, I can rewrite like this. I can rewrite like this: x2 into I cap minus x1 into I cap. I cap is a unit vector along the direction of x-axis, and this we can rewrite like this: x2 minus x1 into I cap. So from this one you can find out that displacement of the car, it is AB bar, which is x2 minus x1 into I cap. Remember, displacement is a vector quantity. Displacement is a vector quantity, and being a vector quantity, it has magnitude as well as direction. It has both magnitude as well as direction. So you have to consider that displacement is a vector quantity. It has a magnitude as well as direction. It has a dimensions of length. It has dimension of length. So its unit, it is meters in SI unit or centimeter in CGS unit. If you want to find out its dimension, it is M0 L1 T0. M0 L1 T0. These are the dimensions of the displacement. Now if you calculate the magnitude of the displacement, you will get a distance covered by the object, which is a scalar quantity. Remember this. We will be using distance term while discussing speed, which we will be discussing in the coming section. Okay, I hope you people have understood what is displacement. Now we'll move to the next term, which is speed. Okay. Okay. Now let us start with the second term, which we'll be discussing now, which is average speed. Okay, so second term, it is average speed. Average speed. Okay, now what is average speed? Average speed, it is defined as the ratio of the amount of distance, the amount of distance covered by the object, divided by the ratio of the amount of the distance covered by the object to the time required to cover that distance. Okay, so this is the definition of average speed. Okay, so you can rewrite in mathematical form: average speed is equal to this is the ratio of total distance covered. So that is total distance divided by the time interval. And if I denote a total distance covered by the object by symbol S and time by T, then it is S by T. So if I ask you to find out its unit, it's very simple. We know that distance is measured in terms of meters or centimeter. So I'll write meters over here, and time is measured in terms of second. Or in CGS unit you can write it in this way, centimeters per second. If you want to find out the dimension of the average speed, the dimension of average speed is equal to its meters per second. So it is L1. L stands for the length, so it is L1, and second stands for the time, as it is per second, so it will come out to be -1. So your dimensions are M0, L1, T minus 1. Remember this, in average speed we are taking a distance which is a scalar quantity, so average speed is also itself a scalar quantity. Now we will move to the next quantity, which is called as instantaneous speed. Instantaneous speed. Now is instantaneous speed, it is nothing but it is an average speed only, but that has been measured at a particular instant. So we will note, we'll first of all write the definition, then we will try to understand. It is the rate at which particles position is changing at a given time. So instantaneous speed is nothing but it is the rate at which the particle's position is changing at a given time. Remember, average speed is calculated over a finite time interval, but instantaneous speed, it is calculated at a given time. Okay, so when I was discussing that object is moving from the point A to point B, it has a fixed average speed, but its instantaneous speed at this point or this point or this point or this point, it may be different. Remember this thing. Okay, so instantaneous speed is a different quantity which is calculated at a given instant of time at a particular point, whereas the average speed is calculated at the over a finite interval. So from point A to point B. Remember this. So it is over a total time interval. I hope you people have understood this. Now remember this, being a speed, instantaneous speed is also a scalar quantity. Remember this thing. Okay, now we will move to the next quantity, that is called as the average velocity. Now we will calculate the next quantity, that is called as the average velocity. Okay, so next quantity, average velocity. Now average velocity of a, first of all we will write down the definition, then we will discuss it. Average velocity of a body, average velocity of a body, average velocity of a body, average velocity of a body is the ratio of the total displacement, is the ratio of the total displacement is defined as the ratio of total displacement and the total time required for that displacement. Okay, so average velocity of a body. So I can rewrite it in a mathematical form. Average velocity is equal to the ratio of total displacement. So I can write it over here. Total displacement. It is the ratio of total displacement and the total time required. For that particular displacement. Okay. So average velocity is the ratio of displacement and time. And in our earlier definition, we have discussed that displacement is a vector quantity. So one vector divided by a scalar number, it is again a vector quantity. So average velocity, it is a vector quantity. Remember this always. Average velocity is a vector quantity. So it has a magnitude as well as the direction. And its unit, it is same to the speed, because displacement is measured in terms of meters and time is measured in terms of seconds. Or in CGS unit you can rewrite like this: centimeters per second. The dimensions are also same like speed only, because this is just the difference is that this is a vector quantity and the speed which we have discussed in our earlier section, that is a scalar quantity. Remember this. Okay. Now, in addition to this, there is another one. Remember, this average velocity is defined over a total interval, or it has been defined over a event. Now we have to discuss the next quantity, which is very important, which will be using while discussing the numericals as well. That is called as the instantaneous speed. Instantaneous velocity. Okay. So now, what is instantaneous velocity? It is the limiting value of the average velocity. We can rewrite. First of all, we will write the definition, then we will see. It is defined as, or you can write, it is the limit of average velocity. It is the limit of average velocity as the time interval. I am talking about the total time. As the time interval approaches to the zero. Okay. So in mathematical language, I can rewrite the instantaneous velocity. Let us call this as a V bar is equal to limit delta t tends to 0. Here let us call this as in case of average velocity, let us call this as total displacement as delta s bar over a finite time interval. Let us call it as delta t bar. So limit delta t tends to 0, delta s bar divided by delta t. In the language of calculus, this limit, it is nothing but the derivative of this one, ds bar by dt. Okay. So in other words, you can rewrite this instantaneous velocity as instantaneous velocity of an object is defined as the rate of change of, because it is changing with time, rate of change of displacement with respect to time. So in other words, we can rewrite this instantaneous velocity like this. I'll write the definition over here. Instantaneous velocity, we will write its definition over here. Instantaneous velocity is defined as the rate of change of displacement, rate of change of displacement with time. Okay, so V is nothing but the rate of change of displacement. Okay, now we will come to the next important quantity which is there, that is called as the acceleration. Okay, the first quantity which we have to discuss is the average acceleration. Average acceleration. Now this average acceleration is defined as it's similar to the velocity. Velocity we have derived from the quantity that is displacement. So now acceleration will be derived from a velocity. So the average acceleration is defined as remember, the velocity, it is a vector quantity. It has magnitude as well as the direction. If you want to change the value of the velocity, you can change the magnitude or you can change the direction of the velocity, then you will get some different value of the velocity. Now here in this case, suppose the velocity of an object is changing. For example, there is an object which is moving on the way. Let us say at point A, its velocity is v1 bar at time t1. Okay, for example, the object is moving from point A to, let us say, point B it is going, and its velocity at point A it is v1 bar, and its velocity at the point B it is v2 bar. Okay, now average acceleration, it is defined as the change in velocity. It is defined as the change in velocity. It is defined as the change in velocity. Change in velocity divided by the time interval. During which that change is occurring. Okay, now see, what is average acceleration? It is defined as the change in velocity. So I will write it over here. Average acceleration is equal to change in velocity. Change in velocity divided by the time interval. So here in this case, the change in velocity, when the object was at the position A, its velocity was v1, and when it is moving from point A to point B, its velocity is v2. So how will you find out the change? It is final velocity minus initial velocity. So let us call it as a v2 bar minus v1 bar. This is equal to time interval, that is t2 minus t1. So this is your average acceleration. And you know that the velocity is measured in terms of meters per second, and this time is measured in terms of seconds. So its unit is meters per second square. Remember, the velocity is a vector quantity, so average acceleration is also a vector quantity. Now we will try to calculate its instantaneous value. Okay, now we will calculate its instantaneous value, that is instantaneous acceleration. The last quantity which is of importance, that is instantaneous acceleration. Likewise, the instantaneous velocity, instantaneous acceleration, it is the limiting value of the average acceleration. By considering this time interval, see, this is nothing but it is delta v bar. this is delta v bar, and this is delta t. So instantaneous acceleration is nothing but the limiting value. Okay, so the limiting value of average acceleration over a time interval tending to zero means this value of this average acceleration when this time interval it is tending to zero. So actually it is, you can rewrite like this, it's a limiting value. So instantaneous acceleration, let us denote it by an a bar. So it is limit delta t, the time interval is tending to zero, delta t tends to zero, it is delta v bar divided by delta t. So this is nothing but, in the language of the calculus, this limit that is called as dv bar by dt. So in other words, you can rewrite this instantaneous acceleration in other way like this. The instantaneous acceleration is defined as the rate of change of velocity with respect to time. The rate of change of velocity with time. So that is an alternative or another definition of instantaneous acceleration. I hope you people have studied, understand this, what is displacement, what is velocity, and what is acceleration. These displacement, velocity and acceleration, these are vector quantities. If you take, we'll just, in order to recap what we have discussed, I'll write it over here. Displacement, velocity and acceleration. If you take a rate of change of displacement with respect to time, you will get a velocity. I am talking about the instantaneous velocity. Okay, the rate of change of displacement with respect to time, you will get the instantaneous velocity. If you take a rate of change of velocity with respect to time, you will get an instantaneous acceleration. And average value, this instantaneous value, remember this, average values are taken over a finite time interval and instantaneous values are taken at a given instant of time. Okay, so displacement, so time derivative will give you the velocity, velocity's time derivative will give you the acceleration. Based on this formalism, we will be discussing few more problems which we will discuss in the next sections. Okay, thank you.